This is the last screencast for the Advanced Thermochemistry Chapter 19. This is for AP Chemistry, and in this in this screencast, we're going to talk about Gibbs free energy and how it relates to equilibrium. In our previous screencast, we talked about that if delta G was negative, then the reaction is spontaneous, and if delta G was positive, then the forward reaction was not spontaneous. However, if delta G was 0, then it was considered to be at equilibrium. So we are going to be able to mathematically connect a delta G equation to an equilibrium value and then solve for various components. So you need to keep in mind that when delta G is 0, that the reaction is at equilibrium, meaning the forward and the reverse reactions are moving at the same rate. Delta G 0, remember the standard molar Gibbs free energy, can be related to our K, or our equilibrium constant. Remember, the equilibrium constant is found by taking the products divided by the reactants. You will raise it to the coefficient, and that's how you calculate K. Most often they're going to give this to you in the problems that you're working with here. Most of our reactions are going to occur at non-standard conditions. Remember, standard conditions are when your solid is considered to be pure and ignored. Liquid is also pure and ignored in equilibrium. The gas is at 1 atm or at atm units. The solutions are in molarity. And an element is in standard state, so it's considered to be 0 for delta H. The equation that we're going to be using for free energy and equilibrium is delta G, so your free energy, equals the standard free energy, delta G 0, plus RT, natural log of Q. R would be the 8.314 joules per mole Kelvin, T in temperature in Kelvin, and Q is our reaction quotient. We find the reaction quotient the same way you find K, except that it is given just the initial values, so just the initial concentrations or pressures for the reaction are plugged into it. Then you will look at Q and compare it to K if we were doing equilibrium problems to decide if the reaction is moving forward or backwards. If Q equals 1 at standard conditions, then the whole product there, the natural log of 1, would allow that to become 0. And so your delta G would equal delta G 0, saying that it's at equilibrium. So as we continue on, we're going to be looking at what does this mean and another form of problem that you can solve for if you don't have delta G, just plain delta G value, because it's at 0, it's at equilibrium. Then we can take, and because Q becomes K when it's at equilibrium as well, you can take and solve those into your equation. And so your ending equation that you will probably most likely be using will be delta G 0, so standard free energy, equals negative RT, natural log of K. R, again, is the 8.314, and this is in joules, mole Kelvin, and T, temperature in Kelvin. Now the natural log of K, so the natural log function on your calculator is a button, and to do the inverse of that, you have to do the e to the x button. This is a function on your calculator just like this is a function on your calculator. So when you do that, if you were solving for K, you would have this variation of the equation. So if you were solving for K, you're going to take the inverse log of negative delta G divided by RT. Some of you will need to practice with that on your calculator, remembering how to use those keys, because it's been a while. That being said, if you get a delta G 0 that is negative, K is much bigger than 1. And if you get a delta G of 0, then K is equal to 1, so at equilibrium. And if you get a delta G 0 that is positive, then K is very small. Now remember, when K is a big number, we are favoring the products, and when K is a small number, we are favoring the reactants. Because, here, I'll put this on the screen for you, K is equal to the products over the reactants. And when you're doing this, I'll even help you out. Let's say we were using A as our substance. We would raise it to the coefficients. It's been a while. I know that you may be looking at this and it's vaguely familiar, but you would do this. So maybe you're solving for K. Maybe they give you K. Maybe you're looking for delta G. There's lots of different options in these problems. You're going to have to read the word problems carefully and decide what information they're giving you.